Okay, now we're going to start working on multiplication and division. Right now we're going to work on multiplication, and what you need to be able to do in 5th grade is to be able to multiply a 3-digit number by a 2-digit number. Last year you needed to be able to multiply a 2-digit number by a 2-digit number. So a little bit harder, but not that bad. We're just kind of extending our skills that we already have worked on over the past few years. So we're going to start that off by with the seating problem. You should have downloaded and printed this, and you should have it ready to work on. So what we need to do is we need to use some base 10 blocks to solve this problem. So you should have downloaded the base 10 blocks manipulative and cut those out, printed those out, and cut them out so that we can use them. You should have, probably a 1,000th grid, maybe a 100th grid, your 10 longs, and your units to use. And so what we need to do is we are not going to discuss and agree on our plan with our partner, but we're going to carry out a plan and think of one. And we're going to use this table right here to record our progress. So the problem that we're working on is a caterer set up chairs for a wedding with 18 chairs in each row. If he did this for 14 rows, how many total chairs were there? So we need to be able to start picturing that we're making rows and columns and putting single things together in order to make a group, and that is multiplication. So first thing that you ought to do is kind of think. I want you to pause the video here in a second and take some time to think about how you can set up and use the base 10 blocks to represent this problem. So go ahead and pause your video now, and then when you're ready, press play and we will check your answer. Okay, so how did you use your base 10 blocks to represent this problem? Well, you may have done something like this, where we have a 100th grid, and then 1, 2, 3, 4 of your 10 longs down here. That means there's 10 units in one. And then 1, 2, 3, 4, 5, whoops. 1, 2, 3, 4, 5, 6, 7, 8 more 10 longs along this side. So we should have 8, 9, 10, 11, 12 of our 10s, and then we have our 1s down here. And we've put them together so that it's not just groups, like we've got our hundredths block and then all of our 10s together and the 1s together. We want to start grouping them so that we get a rectangle that's filled in with all of our units. So, based on, so you could have done this, like I made 14 groups of base 10 blocks with 18 blocks. 1 10 long and 8 units in each group. So we could have done that, like this. 1 10 long and then 8 down at the bottom. That's one way to represent our problem. So when you developed your model, based on that, what is the total number of chairs that the caterer needs to set up? Well, we need a total of 252 chairs, which means we take our 18 chairs for each row and then do the 18 chairs in a row for 14 rows. That's multiplying 18 times 14. Then how are we going to create an array or area model to represent this problem? This is kind of an array or area model. We could group our 10s together and then the units to see if we can form a rectangle, and that's what we did up here. So in words, in this one, we're going to go through and do the seating problem together so that we get the feel for how this type of problem works. We could group the 10s together and then the units together to see if we could get a rectangle. Oops, sorry. I can't seem to grab the right thing here. Hold on. There we go. So in words, we have 14 rows of chairs with 18 chairs in each row, which means we're going to need a total of 252 chairs. So that's how we would represent this problem situation in words. Then we need to represent it in numbers. So we should have 14 rows of chairs with 18 chairs in each row for a total of 252 chairs. Okay, so this is how we're going to work out these problems. You're going to use your base 10 blocks to model it. You need to start working on developing your array or rectangle showing us rows and columns. Okay? So again, are there groups of 10 longs that could be combined and represented with 100 flats in our problem? Yes, there is one group of 10 longs. So when you use the ones that have 10 units in them, and you have 10 of them, you could represent that with a hundredths grid, okay? How many 100 flats can you use to regroup the 10 longs? So we're going to use one of the 100 flats because we only have 10 of the 10 longs that we can put together. This is called regrouping. Then we're going to, are there any groups of units that could be combined and represented with 10 longs? So that means taking the individual unit squares, and then we would probably need 10 of the units each in order to get to regroup and trade those in for a 10 long. Okay? So we can do that 8 times. So we're going to pull out 8 groups of the 10 longs. How many 10 longs were you able to regroup? 8 of the 10 longs. Does the arrangement of the base 10 blocks change the value of the area model? No, we're still using the same number of base 10 blocks to fill the area. So you could have just pulled out 252, or you could have, let's see, you could have made